Quantum technology has been the subject of science fiction, literature, film, and television for decades. But competition to build the world's first large-scale quantum computer is heating up. It's becoming much less fiction and more science. As the field grows, so do the claims. In this episode of Field Notes, we'll try to separate the facts from the fiction and the hype from the reality. Episode 3, Quantum Computing, Hype versus Reality. First up, do quantum computers even exist yet?
So does a quantum computer exist? It kind of depends on exactly what we mean by computer. Quantum computers exist in kind of their infant form and are not universally or generally useful, but physically the hardware does exist.
Right now, Google has the largest effective quantum volume in the world today, meaning it's got the most powerful quantum processor to date. And even with that, the team is still in the experimental research phase. So a useful, large-scale, error-corrected quantum computer that solves lots of practical, real-world problems is still a ways off. At Google Quantum AI, it's believed to happen within the decade, maybe with a few extra years to get into the groove with useful applications. But some fascinating things could start to happen even before then. There may be a gradual increase in spikes of usefulness for very niche applications before things broaden out. Think of it like what happened with classic computer processing units. They were initially developed for very specific simulation tasks. Over time, as the technology progressed, people figured out new, unexpected applications. Quantum computing is likely to follow the same path. So, as quantum computers become more useful, will they do everything better than a classical computer? Well, no. Most computation tasks will still continue to be done with cheaper, leaner classical computers. Quantum computers will be used on problems where a quantum algorithm gives an exponential advantage over a classical algorithm.
In a way, it's just another tool that we can add to the toolbox.
One hopeful use for quantum computers is to help to advance fusion as a source of clean energy. During fusion experiments, scientists direct lasers at a plasma target to create heat and trigger fusion, with the end goal of getting more energy out than what they put in. But to fine-tune their experiments, they need to be able to simulate how heat moves in and how energy is lost. Researchers have been using classical computers to simulate fusion reactions, but it has its drawbacks.
Simulation is pretty expensive to do, and we know it's very coarse. There's uncontrolled error in that simulation at very large expense, so hundreds of millions of CPU hours.
Quantum computing could run fusion simulations much quicker and with a higher fidelity.
Because then you're simulating the quantum mechanical equations exactly. You're not making any approximations. And for about the same cost, you can get a much higher accuracy simulation, which is sort of what we need to develop the technology.
There are many other possible applications too. We might be able to model the behavior of potential new drugs, or simulate the electrochemistry inside batteries to make them more efficient, or even simulate the chemistry of making fertilizer so the whole process is greener. Quantum computing will also be useful in ways that haven't been imagined yet. As you can see, the world of quantum computing is getting exciting. The technology that once felt like a piece of fiction is becoming more real every day. To find out more and stay up to date with the Google Quantum AI team, click the link in the description.